Hello, everyone. Today we will talk about a very interesting topic, which is a satellite communication system. So before continuing with our discussion, let me introduce myself. My name is Umaid Ahmadi, and I have a master's degree in telecommunication system from University of Maryland and a bachelor's degree in electronics and communication engineering. So we will start our discussion with a brief history of satellite communication system. Then I will answer the question, why do we need satellites? I will explain the logic and principle behind using satellites. Then we will do the classification of satellites based on its orbit. And also we will name some of the applications of satellite communication system. And finally, we will talk about some of the challenges that satellite communication system have. So before continuing with this presentation, let me ask you a very interesting question. So what is the name of our planet's first satellite? I will give you a hint. We see it every night. Well, especially if the sky is clear. So if you came up with the answer of moon, that's right. Moon is our planet's first satellite. So what is a satellite? A satellite is an object which rotates around another object, for example, a planet. And the moon is just doing that. But when we hear the name of satellite, we usually think of artificial satellites or man-made satellites. So in this discussion, we will talk about artificial satellites. So it all began on October 4th, 1957, when Russians launched their first satellite into the orbit, and they named it Sputnik 1. Sputnik 1 was very small in size, around this much, and it stayed operational for a very brief period of time, for around 20 days. This is the picture of Sputnik 1. Russians didn't stop there. On November 3rd, 1957, Russians launched another satellite with the name of Sputnik 2. And this time, the Sputnik 2 also carried a living passenger. His name was Laika. So if you haven't seen the picture of Laika, here he is. Unfortunately, Laika didn't made it back to Earth because of the time's technology, which was not very advanced to have a round trip for Laika. A sad story indeed. When Americans heard this huge success story of Russians, they panicked. So after the 2 months after the release of Sputnik 2, Americans launched their first satellite into space. They named it Explorer 1. This is the picture of Explorer 1. Explorer 1 was very small in size compared to Sputnik 2. Since then, 8,900 satellites have been launched from 40 different countries. Out of this 8,900 satellites, 1,900 satellites are currently operational, and the rest 700 have turned into space junk. Now, let's name the top 3 countries with the most satellites operational in this space. The first country is United States with 859 satellites operational. The second country is China with the total number of 250 satellites. And the third country is Russia with 146 satellites. Now, let's answer this question, why do we need satellites? Now, suppose that we have a transmitter and a receiver in a flat surface, and they want to communicate with each other. Now, because we do not have any obstacle in between this transmitter and receiver, so the communication will be very easy. They will have a line of sight and they will have a direct communication with each other. Now, imagine that this surface is not flat; it's curved like our Earth, and Mount Everest is also sitting in between these two transmitter and receiver. So, how these two guys here will communicate with each other? So here comes our satellite for the rescue. So the satellite will take their signal from the transmitter. The transmitter will actually send the signal to the satellite. Satellite will amplify the signal, process the signal, and filter the signal, and then send it back to the receiver on the other side of the planet. So we can say that a satellite is a kind of like a repeater. It takes signal from a transmitter, process it and broadcast it into the users on the other side of the planet or on the other side of the continent. Now let's do the classification of satellite. Satellites are classified into geostationary orbit satellites and non-geostationary orbits. Non-geostationary satellites are in turn classified into medium Earth orbit satellites, or MEO, or low Earth orbit satellites, and low LEO. So now let's discuss a little further in detail these three kinds of satellites. Geostationary satellites are very high in the space. The distance from the surface of Earth is around 35,790 kilometers, while medium Earth satellites in low Earth orbit satellites are comparatively near to the Earth's surface. Now, because the geostationary satellites are very high in altitude, they will cover a very large surface area of planet Earth. It's around 40% of the surface will be covered by a single geostationary satellite. This coverage is comparatively very low in medium Earth orbit and low Earth orbit because of their distance, their altitude from the surface. Now, because geostationary satellites are very high in the orbit, the signal will take longer time for the signal to travel from the ground station to the satellite. It will take approximately 250 milliseconds for a signal to reach from the ground station to the satellite. This delay is very high. For that reason, geostationary satellites are not used for communication purposes. They are used for broadcasting of television and radio signals. This delay is very less in low Earth orbit satellites because of their proximity to the Earth's surface. For that reason, low Earth orbit satellites are used for communication purposes. Now, because geostationary satellites are very high in the orbit, they will also have longer lifespan because they will have less fraction from the atmosphere, and also the gravitational force will be lower on them. Now let's do some maths here. In this slide, we will calculate the speed of our LEO satellites. Now we know that the radius of the LEO satellites is 6,400 kilometers from satellite to the center of Earth, and it will take 84 minutes for the satellite to complete one rotation around the planet Earth. So in order to calculate the speed, we have the formula, which is equal to speed. We know that the speed equal to distance traveled by an object divided by the time it took for that object to travel that distance. So in our case, the satellites are now not traveling in a flat surface. They are traveling around the Earth, which is circular. So we will use the formula of a circle, the circumference of a circle, to find the distance traveled by the satellite. So we know that the circumference of a circle, the formula is 2 pi multiplied by the radius. To substitute the number in this formula, we have 2 pi multiplied by the radius, which is 6,400 kilometers, and we will get 40,212 kilometers, which means that the satellites will have to travel 40,212 kilometers to complete one circle. And we know that it takes 84 minutes for the satellite to complete this distance. So the speed will be equal to 40,212 kilometers divided by 84 minutes, which will be equal to 478 kilometers per minute. So now let's convert this number to kilometers per hour, which is much more convenient for our calculations. So we will multiply this number by 60 because the number of minutes in 1 hour is 60. So we will get to 28,680 kilometers per hour, which is very high speed. So our LEO satellites will have the speed of 28,680 kilometers. And if we compare this speed with the speed of our commercial airplanes, we know that the commercial airplanes have a speed of 950 kilometers per hour. So it means that our satellite will be 30 times faster than the commercial airplane, which is very fast. And if we compare this speed with the speed of a bullet, the speed of a bullet is approximately 3,000 kilometers per hour, which means that the satellites will be traveling 9 times faster than the speed of bullet. Now let's name some of the applications of satellite system. Satellites are mainly used for communication purposes. In fact, 60% of the satellites are used for this purpose. It's not just the stationary communication in the ground, but also we can use satellite communication. We can make a phone call from a moving aeroplane. The second application is navigation. GPS is one of the examples. We have GPS devices in our cars, in our phones, and without GPS, our navigation system will not be the same. We will not have the same exploration and also finding the ways. Survey is another application of satellite systems. We use satellites in geographical surveys, geological surveys, minings, and also agriculture surveys. Weather is another application for satellites. With the help of satellites, now we can do the weather predictions more accurately. And also we can prevent a natural disaster, before it happens. Broadcasting is another application of satellite systems. Now we can have access to HD television in the middle of a desert. Before the satellites, this kind of luxury was not possible. These were some of the applications of satellite system. There are dozens of other applications, for example, military applications, marine application, and many more. Let's now talk about some of the challenges of satellite systems. It's very costly to deploy a satellite. It is not just the cost of $1 million, but also it needs a very high technology of rocket science to deploy a satellite into in the orbit. For that reason, only 40 countries have satellites right now in the space. Once you deploy the satellites, another challenge is positioning of the satellites into the orbit. You have to carefully position the satellite so that it will not collide with someone else's property. So it will not collide with someone else's satellite also. Once you position the satellite, stability is another challenge. The satellite should have a very predefined and pre-calculated speed so that it will not be fast enough so that it will leave the planet Earth and you will lose millions of dollars of property. And also it should not be very slow so that it will fall back to the planet Earth, which will cause you not just $1 million property, but also it may have some casualties. Power is another challenge in satellite communication system. Although with the advent of batteries and advanced solar panels, this issue has been resolved somehow, but still there is improvement needed in this department. Nuclear power can also be used as a source for satellite communication, satellite systems, but because of their instability and they are highly dangerous and they are not recommended. We know that space is a hostile environment. So the device which we are using on the planet Earth, it will not be functional in the space. So we have to carefully design our equipment such that it will not burn out quickly in this space. So satellites are still in its preliminary stages of development. In the future, we will not only have satellites around the planet Earth and our solar system, but we will have satellites around other extraterrestrial objects, which will give us a better understanding of our universe. Also, satellites have given us the promise of high-speed internet connectivity all around the world. In fact, Starlink company of Elon Musk, they have promised that by the end of 2022, they will launch a network of satellites which will cover the majority of the space, the surface of the Earth, and they will provide high-speed internet with very low latency to everyone. Thank you everyone for your attention. If you have any questions, please write them on the comment section below. And like the video if you really like this presentation. Thank you very much. Have a good day.